Hello engineers. In this lesson we are going to discover how to work with internet connection, get some data from internet and combine it with physical input-output lines. So we have an electric circuit, we have a button, and we will implement the next feature. When we press the button, our application will make a request to internet weather service, get the temperature, the current temperature, and if the temperature is above zero, the green LED will blink how many times that the current temperature. If it will be the below zero, the red LED will blinking. If it's zero, two LEDs will blink only once. Okay, let's do it and check how it works. I'm pressing the button. 1, 2, 3, 4, 5, 6, 7. Okay, it's -7 below zero. Actually, this is a current temperature and we got it from async internet request call. We already have our project from previous lessons and it's already pretty complicated. So let's make some order and more easy structure for it. In our core package we have two packages. Avatar. In this package all logic about hardware devices. So like just imagine our robot have a body and all logic about physical body and interactions in this package. Our runtime package it's everything about runtime work services and configurations and applications settings. What we need else? Just imagine if it's a complicated robot with artificial intelligence. Probably we need something about environment, some data and logic about a real world and environment where a robot will interact. So let's create this package. Environment. Okay. The next package, what we need, it's a network. Actually, this is an agenda for this lesson. Network. We will discover how to work with internet connection, get some data, and combine it with physical input-output lines. And one interesting package, I want to make these robots more humankind. So just imagine we like a human, we have a body and we have a brain what control our body, our behavior. So let's do the same. All decisions, all logic about artificial intelligence and interaction with world, with environment will be in the brain package. Okay, that's good. and how we can combine internet connection and physical input-output lines. So far we have only LEDs as output devices. So maybe we can check the actual weather for our current region and output it with using LEDs. Okay, no problem. So what we need? We need some free weather API service. Let's search it. Weather API. Let's choose the first one. Okay, so all what you need, it's a create new account for studying, for personal using. It's a totally free account. They saying 1000 API calls per day. It's free. It's more than enough for us. And we need API actually. So click API, and we need a current weather data. Let's look into API. All what we need for now, it's find weather by city name, because I guess you know where you are living right now. They have a weather by GPS coordinates, but this is not an agenda for current lesson. When we will discover position centers with GPS coordinates, we can use and modify this service. But for today, we just need get weather by city name. So if you're not familiar with REST API, I'll explain what is this. So basically, when we have like weather API, this is Google search. This is as a URL to Google, and we have some information. So we making a request inside the URL, and when we making a request, we can set a city name, and we need a personal API key. When you register, you will generate the API key for access to this service and inject it as a parameter. But what I discovered yesterday, the API key doesn't working immediately. So I was waiting around 1 hour to get access to it. And you can check how it works in Postman. So this is a simple GET request. As you can see, we injecting 3 parameters. So the city, our API key. I'll leave this key in Git repository, and you can use mine if you don't want to register. And we need as parameter metric temperature in Celsius or in Fahrenheit. So metric or imperial units. And if we make a request, we can see the response. The coordinates of our city, a lot of information, but we need basic information, the temperature right now. Okay, what we need to work with REST API and internet connections. Java and Kotlin has a retrofit library. It's very powerful library, and I'll show how to work with it. So Java retrofit. If you Google it, you can see how to work with it. So we need to create some interfaces to which URL with parameters, and we need an object to operate with our service and internet calls. Here is how it's building. It's using a Java language, but we can easily implement it in Kotlin. Okay, first of all what we need, it's a dependency injections. Some dependencies, let's copy it, and goes to our POM XML. We already have a lot of dependencies, by the way, so we need 3 dependencies. This is a retrofit core to operate with our internet calls. This is how we parsing the response from internet call. So it's a JSON structure, and we need to parse it to our local data objects. And the third one, it's a OC HTTP interceptor. So this is like a network layer. Retrofit and OC HTTP, they work in pair. You can add some interceptors to this library. For example, if you need an authentication before you make a network call, you can add some checks, verifications, but we don't need to work with it today. I'll explain maybe later if you want it. Okay, we already have all packages, so let's make some object what will return our retrofit internet connection. In package network we will create a internet connection. Okay, let's do it. First of all, we need an OC HTTP. Let me explain one important thing. When you initialize a retrofit connection, it has one of the parameters, call it the base URL. So in Postman you can see this is like the base URL, the domain address, and you can make multiple different calls to different services. This part, so this part of internet call, internet request, always the same, and when we initialize retrofit service we should to say what's the base URL. But if you in your application, if you have a different logic with network, like weather services, some interaction with remote databases and logging, and interaction through remote control through internet, something like that. So we can change the base URL dynamically, but you can miss the point. So it's better, I'm recommending to create a few instances of retrofit with base URL. So we need a single OC HTTP client, but we need a multiple retrofit connectors For today we need only once, but I'm just explaining how it works. So awk HTTP client. Oh, I believe I forgot to synchronize. Yes, so it's not appearing. Now it's appearing, and let's make it null and initialize only once and use in multiple retrofit connections. So first of all, we need to initialize it. Let's make this function private because we don't need to use it outside of this class, of this object. Get awk HTTP client without the parameters, awk HTTP client, and return awk HTTP client new builder. Here we can add interceptors if need and build. Yes, so okay, and public function fun. Here will be a get weather client, because for weather client we have one base rule. For other clients, like for example function get, I don't know, something like get my mile, we will have the base rule connect to your mile service. So we need base URL string as incoming parameter and retro fit. Okay, let's import it and return retrofit builder and set it client. We need our awk HTTP client. We don't know is it nullable or not. So if it's nullable, if it's not nullable, it's already implemented. We have the fillet value. We can use it awk HTTP client. If it's null, how to check it? It's very easy in Kotlin. Get awk HTTP client. Okay, then we can base URL as base URL, and we need add a converter factory, convert the remote response to our local object. We need a JSON converter factory. Create and build. Yes. So to build a retrofit client, we need an awk HTTP stack, our base rule to convert remote data, and make a command build this instance of retrofit. Okay. So in network we can have multiple services. Let's make a package for service, call it weather service. We need, first of all, an API for it as interface. API. And let's look in this service to retrofit. How to make an API service. Something like that. Okay. Let's make, first of all, it will be a GET service. And we already have a base URL, so we need this part, of our service. Yep. Okay. Fun. Get weather by name and some incoming parameters. Cool. Query. Let's look our incoming parameters. What are they telling to us? At least city and API key, and it doesn't working with additional parameter units. We will use metric system, but you can use BRL if it's your region. Okay, we need app ID for basic authentication. App ID, it's a string. Yes. And two more parameter. Q, it's the name of our current city. And units, yes, units. So this is a local name of our incoming parameter, and this will be the name of parameter when we make a request, and the type. So call, it will return. So we need our local data class. Let's look what are they telling. We need JSON format, API response example. So we can easily use it. This is the JSON object, what will be returned. Okay, let's copy it. And from the previous lessons, you already know we have a magic tool after generator of data classes, Kotlin data classes from JSON objects. Perfect. So here we will create a data package for data classes and generate Kotlin data class from JSON. Let's not, what's happening? Copy. Oh, I pressed wrong button. Yahoo! And the name of the file, weather response. So this is a default settings for it. We don't need an annotation, but if you want to use different local names of the values, and remote, you can mark it as Jackson and change it. But for the simplification, we will not activate this feature. And enable inner class model. Okay, let's generate it. Boom. Very, very good. And the type of response will be weather response. Okay. The next, we need some network service to work with everything of this, and call it from the main thread. Okay, not in this package. Let's create a class, call it weather network service. First of all, we need a base URL, because sometimes it could be changed anytime. We are not the owners of this public service. So we need a const val where the base URL, and the name. This. Do not forget to set slash at the end of the domain address. So we need a client, a retrofit client. Let's make it private val client, and as internet connection and object, we can directly call get and set base URL as parameter. Okay, and we need an instance of our API to work with it, to know how to make requests. Well, API service client create and receive the name of the class. We have API as Java class. Perfect. Let's create a public function to make a function for it. Sorry, I'm thinking get weather by name, because in the same weather service we can have multiple services, like get weather for the next 2 weeks or something like that. What we need as incoming parameter, of course, city and units as string. By default it will be metric system. Okay, let's make a request and get response immediately. Response API service get weather by name, because in our API class we have current function. Okay, and receive the parameters. Also, we need our public key or private key. I'm recommending to store all settings somewhere in package runtime setup. So let's create a companion object for it. For settings. Const val weather API key, and I can share with you my key one more time if you don't want to register in that weather service. Okay, let's return by here what we need to set as parameter: app ID, settings, weather API key, city, we receiving incoming parameter, and units as units, and call execute function, so make a async request. Okay, what we need when we get our response, by the way, it may be successful or unsuccessful, so you have a problems with your internet connection, we should to add some checks for it. How we notify our main thread that we have some data and some logic should be launched and refreshed. In Kotlin we have a flows. For example, Kotlin flow. It's using in Android, but no, we need a shared flow. Shared flow. So this is an object what have a subscribers, and when this object is refreshing, getting some new data, it's notifying all its subscribers that I have a data, you can work with it, hey, like that. So it's an interaction inside our application. So makes sense to create some package in our brain for emitters. So to emit actions, events, data, and etc. etc. Okay, perfect. And let's make some emitter for network service, because we can have some emitters from sensors, like a distance sensors. It's measuring the distance in real time and notifying our application, I have a fresh data, let's work with it. So let's create network emitters as object, of course. to work with it without initialization. First of all, I'll show you. From our response, we already have from retrofit some useful information. We have a body with our actual weather if the request was successful. We have a code. This is HTTP stack code. So if it's a code 200, it means okay. If it's a 404, maybe you saw when you trying to load some web pages what doesn't exist, you see this page doesn't exist and code 404. So we need this code to recognize, and we have a message. So it's a some message and data about our network request. Okay, we don't need this, but we need to create data class with all actual information about network call. Weather data. Wow. Weather response. Weather response. It could be null, of course. We don't know. Do we have an internet connection or not? We have is successful Boolean state. By default, I recommend to set it to false. We have an HTTP code. HTTP code as int, set it like that, and we have our message as string. Okay, let's create Kotlin shared flows. First flow should be as mutable to refresh the data, but it should be private. We don't need to have an access to this flow. Where there emitter table shared flow with type. Why we created this data class? Kotlin flow need a type to collecting the data, and while weather emitter we transforming this as shared flow. So this is a not rewritable flow, and from other threads, from main thread, we have an access to only this public flow, but we work with private flow. Okay, and fun emit weather response when we have data from retrofit. All Kotlin flows should be updated only from coroutine scope, so from multi-threading job. Coroutine scope, set it to dispatcher's input output layer and launch. Okay, very easy. One string, emit our data. Yes. Perfect. Let's return to our service. When we have a data, let's emit it. Network emitters, emit weather response, and we have to build our data class. Weather response. We don't know. Do we have actual weather or not? It depends. It depends. It depends. Was our response successful or not? So if it's successful, return response body. Else, no. Perfect. Does it make sense for you? Is successful. Response is successful. HTTP code. Response code. And message. Response message. So we wrapping and mapping our remote data to our local data. Yeah, that's all I believe. So how we can work with it? Let's go to our main thread. First of all, we need to initialize our weather service to make some calls. Wow. Weather network service. Very easy so far. Okay, we have a logic to work with buttons from previous lessons, but we don't need it. We want to press button. By pressing button, make some network request and subscribe to emitters and output it to LEDs. Okay. Action low, we don't need all this logic, but we need to pass the parameter when releasing the button, just do nothing. Let's copy it. And when we're pressing the button, we just make a city. My city is Toronto. Okay. How we know that we're getting a response? Just subscribe to one of our emitters from main thread, and the magic of Kotlin shared flows, you can subscribe it from multiple places, and this flow notify all parts of our application at the same time. So you can do some job from main thread, then you can log it, then you send the data to other destination and do it at the same time. So network emitters, we have one of our emitters, weather emitter, collecting data. So weather, let's do some checks because we don't know what data we have. If weather is successful and weather response is not null. Let's println weather. Just look in it. Then we have our temperature. Let's look into the response. Temp as double. We need to modify it as integer parameter. So map it our temp as weather response mine temp to int. Okay, perfect. Then coroutine scope, work with a Y coroutine scope because we need to make some delays between blinking, like 1-2 seconds. So we can do it only in coroutine scope launch and additional check if temperature. So this is, I'll explain, this is the case when the temperature equals 0. Yes. Is it possible? It's not a positive temperature, it's not negative, it's directly 0. So we need to turn on 2-hour LEDs for 1 second. This is a green LED, this is a red LED. Okay. This is the case when the temperature equals 0. Next case, else if the same temperature not equals null, null safety check, and the temperature above 0. So we need our green LED, but we need to blink it in loop. So for in 1 2-hour temp. Perfect. Let's blink the green LED for 1 second, then we should to pass a delay. So this string will be implemented immediately in runtime. It will not wait for 1 second because the other threads on a body layer we use thread scope. So we need a delay for 2 seconds. 1 second it's turning on, and 2 seconds this 1 second for turning off, and the next cycle of loop. Okay, and else if, where is our loop iteration? The next case when it's very cold and we have a negative temperature, not null, and our temp below 0. Okay, the same, very easy, you can copy it, but we will use a red letter. So that's all, and we already don't need this empty permanent loop. I believe that's all. We can launch it and check how it works. Okay, it's compiling and pushing to the remote Raspberry Pi. Okay, let's press the button. Yeah, it works. So as you can see, we have a better response. Code 200. It means we have a data. Main feels like -15. Oh my god, it's cold. Where is the temp? -8. Yes. Else if that's good, everything it's okay. Congratulations. That's all for today. Subscribe to my channel and comment it if you want to discover anything else from a programming or physical devices world. Just ask me. I'm trying to be useful. Thank you very much. I forgot to add one important moment. When we have a negative temperature, our chamfer is negative, so this loop never will be launched. We need a model of our temperature. So in Kotlin we have ABS function returning always a positive. Do not forget about this one. Thank you.